Have you ever wondered if you could travel back in time and alter some decisions you made, how different your life would be today? There's a certain allure to the concept of time travel. It's a fascination that has captured our collective imaginations, a tantalizing prospect that promises us a chance to revisit the past, to change the course of our lives, to rewrite our stories in ways we could only dream of. But is time travel merely a figment of our imaginations, or could it actually be possible? To explore the possibilities of time travel, we first need to understand what it is. Time travel, at its simplest, is the concept of moving between different points in time, either to the future or the past, much like we move in space. It's a popular theme in science fiction, but it's also a serious topic in physics. According to Einstein's theory of relativity, time is not a constant but something that can be altered by gravity and speed. Imagine you're on a spaceship traveling close to the speed of light. Time would pass more slowly for you than for someone on Earth. This is called time dilation, and it's a form of forward time travel. Astronauts on the International Space Station, for instance, age slightly slower than people on Earth due to their high speed. However, this effect is minuscule because their speed is nowhere near the speed of light. Now, let's talk about traveling backwards in time. This is where things get complicated. Some theories suggest that certain particles known as tachyons might travel faster than light, which could theoretically allow for backwards time travel, but these particles are purely hypothetical and have not been detected yet. Another concept is the existence of wormholes, shortcuts through space and time, predicted by Einstein's theory. If a wormhole could be stabilized, it might be possible to travel through it to a different point in time. But stabilizing a wormhole would require a form of matter with negative energy, which is also purely theoretical at this point. Moreover, backward time travel opens up a host of paradoxes. For instance, the grandfather paradox, where a time traveler goes back in time and prevents his grandparents from meeting, thereby preventing his own existence. This paradox raises questions about the very nature of time and reality. So with our current understanding of physics, traveling forward in time seems possible. However, traveling backwards is where things get a bit tricky. Imagine you could go back in time and stop your parents from meeting. Would you still exist to have made that trip in the first place? This hypothetical situation introduces us to the concept of the grandfather paradox, a classic illustration of the complexities of time travel. The grandfather paradox is a thought experiment in the philosophy of time travel. It goes like this. Suppose you were to travel back in time and, intentionally or not, cause the death of your grandfather before he met your grandmother. This would result in one of your parents never being born and therefore you never being born. But if you were never born, then how could you have gone back in time to cause your grandfather's death? This paradox presents a major problem for the concept of time travel and hints at the possibility of what physicists call closed time-like curves, where the timeline circles back on itself. But the grandfather paradox is not the only stumbling block. There's also the bootstrap paradox, which involves items or information that are sent back in time, resulting in an infinite loop where the item or information has no discernible origin. And then there's the predestination paradox, where a time traveler's actions in the past are actually what set their present actions in motion. These paradoxes make the concept of time travel seem impossible. But there are still theories that suggest otherwise. While classical physics might have a problem with time travel, quantum physics could potentially make it possible. Quantum physics is the study of the very small, the subatomic level, where the laws of classical physics no longer apply. Here, particles can exist in multiple places at once, teleport across barriers, and even change their behavior when they're observed. It's a world that seems to defy common sense, and it's this very peculiarity that suggests time travel might just be within the realm of possibility. Let's start with the concept of quantum entanglement. This is a phenomenon where two particles become intrinsically linked, such that the state of one instantly affects the other, no matter how far apart they are. Some scientists theorize that if these entangled particles were sent through time instead of space, it could open up a pathway for time travel. Another theory revolves around quantum superposition, the idea that a particle can exist in all its theoretically possible states at once. This means that it's not just in one place at one time, but everywhere at every time. Now, if we could somehow harness this superposition, we could potentially travel through time by simply shifting our state from one time to another. Then there's the concept of quantum tunneling, a process where particles can pass through barriers that should be, according to classical physics, impenetrable. This suggests that if time were perceived as a barrier, it may be possible to tunnel through it, effectively moving from one point in time to another. However, it's important to note that these are all theories, and the reality of time travel is still a subject of intense debate among scientists. There are many challenges to overcome, not least of which is the fact that we're dealing with the realm of the very small, and translating these effects to the macroscopic world we live in is a massive leap. So, while the possibility of time travel is still a hotly debated topic, it's clear that it's more than just a product of our imaginations. Time travel, a concept that fascinates, bewilders, and sometimes terrifies us. We've journeyed together through the complexities of time travel, starting with a basic understanding of what it implies. We've delved into the idea of moving forward or backward through time, revealing the alluring prospect of venturing into the unknown future or revisiting the tangible past. We've wrestled with paradoxes, those mind-bending situations where cause and effect become tangled in a time loop. The grandfather paradox, the bootstrap paradox, these mental gymnastics challenge our understanding of linear time and consequences. Then, we touched upon the realm of quantum physics, where the rules of the macro world don't apply. Quantum superposition, entanglement, and the fascinating theory of quantum tunneling, these could be the building blocks of a time machine. Whether time travel will ever be possible remains to be seen, but one thing is for sure, it's a concept that will continue to intrigue us for generations to come.